So here they remove circuits with dual control switches. That's all right.
Yes, ma'am. Yeah.
So now fuse. First one is fuse. So already we discussed about the fuse, right? So
Yes.
yes. So MCB. MCB means what?
You mind circuit breaker?
Main circuit breaker.
Main circuit.
So fuse is a MCB because the main fuse is connected in the live wire. So after the kilowatt hour meter and before the main circuit. In main circuit, both we will connect live wire and neutral wire. But in the main fuse, only connecting the live wire. Right. So the fuse protects the circuit by blowing off when current in the circuit exceeds. When the current is exceeds, so the fuse protects. So these things and all already we discussed. So once I'll read it and we'll go the next topic. So the current carrying capacity of the fuse due to the current being either overloaded. Already I told you. What is overloaded means here we are taking for example 30 ampere for the house. Actually for house we are taking 30 ampere. So more than 30 ampere it comes means overload.
Yes.
Okay, that is the overload we are saying. So short circuited or we will say the overloaded another name we will say short
Yes.
circuited. So a fuse is connected with each electrical appliances to safeguard. So if flow of current is excess, so it's a safe limit of the current.
Yes.
Mm. Okay. So next is a fuse wire permits the flow of current through it only up to a certain fixed limit. So certain fixed limit only the fuse wire will allow the current. That is called the rating, current rating. So each applicant has a some certain current rating. Okay. So if you see, for example, bulb is having less than 5 ampere current rating. Okay. Fan, bulb, these are current less than 5 ampere or equals to 5 ampere. And more higher current rating appliances are 15 ampere it has. So that is called the current rating, the limit of the certain limit. So as the current exceeds this limit, the temperature of the fuse wire reaches the melting point to break the circuit. Okay, so the wire melts, so the circuit gets broken. Okay, next principle. So a fuse works on the heating effect of the current. Heating effect of the current. A fuse wire of length is L and radius is R and specific resistance is rho. So then resistance R equals to rho L by pi R square. We know that. So we will, this is formula already you learned in the previous chapters, right? So resistance equals to specific resistance and L by pi r square. So heat. So it is based on the heating effect. Heating effect formula is what? I square R. This is also in previous chapter it is there. So H equals to I square R. Then R is rho L by pi R square. So now the T, capital T, we are taking temperature surrounding of the fuse wire, and delta T is the rise in its temperature. Then loss of heat by the radiation in there per second is H equals to 4 sigma T cube delta T into 2 pi RL.
Yes.
So here this sigma is what? Is a constant. It is a conductivity. Sigma is a conductivity. Okay, that conductor we are taking, right? That conductor conductivity, the sigma. And T is a surrounding temperature. And delta T is a rate of change, changing that, rises and decreases, that means. So delta T, some slight changes in the temperature. And 2 pi r L. 2 pi r means we are taking only the boundary, circumference of that. So L is a length. Yeah, why we are taking 2 pi r L means, so suppose that is a wire. So wire is also form of a circles. Understanding, Tejas? So each is a circumference 2 pi r, complete length we need, so into L. So now this is equals to this one, equation 1, equation 2 we are equating. Then we will get I square rho L by pi r square equals to 4 sigma T cube delta T 2 pi r L. So now delta T we need everything sent this side. So delta T equals to I square rho L by pi r square by 4 sigma T cube delta T. Oh, delta T only we are writing. So 2 pi R L. So now here L cancelled. That's all. This 2 pi R square will multiply. So I square rho by 4 2s are 8 sigma T cube pi square R cube. This is only delta T. Only L only cancelled in this derivation. So from this we can write delta T is proportional to the I square by R cube. If you see here, all it is a constant. So I and R only we will compare here. So I is a current. So the rate of change of temperature is depending upon the current and radius. Okay. So if current increases, the rate of change is also increases. If the radius is increases, the rate of temperature is decreases. Yes, it's a right. If the radius is increasing, temperature will reduce. Okay. So when current is flowing through, the temperature is increases, rises. Okay. So here example, they given one example. A fuse wire of current rating is 1 ampere of radius 0.2 millimeter. So the fuse wire of current rating is 8 ampere. So radius is 0.8 millimeter. So thickness of the fuse wire depends upon its current rating. This is the thickness. It is depending upon what? current rating. So higher the current rating. If thickness is increases, so it has to current rating is higher. Its current rating is high. Okay. Next, material of fuse. So material of fuse. So what type of material we have to use of the fuse means copper or aluminum, because specific resistance is more.
More.
Okay, that's why we are using copper or aluminum in the fuse material. So why we are using copper or aluminum means, so if it is melting point is high melting point, copper and aluminum. So if a current exceeds, also it will not melt, and it also saves the limit. The copper and aluminum saves the limit. So here they given construction in the textbook. You can see in 220 page number. So fuse arrangement they have given. Right. So next, how the socket is connecting also they have given. So one is the, so in fuse wire, in fuse they are connecting only the live wire. Neutral wire is not connected to the fuse. So function of the fuse they have given. So what is the function of the fuse?
It prevents excess of current.
If you see here, they given clearly. This is only they will change in the fuse. Here,
Yeah.
yeah. So if you see, this is a glass case. So inside the fuse wire is there, and it is a metal caps. If the more the current rating comes, it melts. Here it melts. So this thing only changing of that. So when the current is in the circuit is exceeds, so what is happened? The temperature of the fuse wire is rises. Then it melts. So a gap is produced, the current breaks. So then the current does not flows through the live wire. That is the functioning of the fuse. Understand, Tejas? These words is important. So if what is the functioning of the fuse and what are the applications of the fuse means, you have to write this. So functioning means when the current in the circuit exceeds, that means it's a overloaded, that means high voltage or short circuit. What will happen? The temperature of the fuse wire is rises, and it melts. Then a gap is produced, then circuit is breaks, so the current does not flows through the live wire to the appliances. So it saved the appliances. After removing the fault in the circuit, a new fuse wire of the same current rating is connected to the holder. Next, reason for connecting the fuse in the live wire. So why we are connecting fuse in the live wire? What is the functioning
Because
of the live wire?
events like if the fuse wire is connected to any other wire, when it's connected to the appliance, and then we get there's an electric shock.
No, wrong.
Yeah.
What is
Yeah.
the functioning of live wire? You are telling about the earth wire.
Earth wire.
Ah,
Yeah.
I am asking about live wire. Totally how many wires are there? 3 wires, right? Live
Three
wire,
wires.
neutral wire,
Earth
earth wire.
each wire.
So yeah, live wire functioning is what? It's carry a current to the, it's a source. It's a carrying
Source.
current to the all the appliances.
As
That is the
as
functioning of the live wire. Neutral wire is
yeah.
what? It gets
No,
back.
it's that.
Gets backs
Okay.
the current to the source.
Yes.
And earth wire is prevent the current
Prevents
shock.
the shock.
Current
And
shock. Okay. So here fuse wire connecting only the live wire. The earth wire and neutral wire is not connecting to the fuse wire. Why? So we have to prevent the appliances from the high current rating. So from main circuit to the main circuit to the main fuse, the live wire is coming. Okay. So always the fuse is connected in the live wire before the appliances. Before the appliances goes to the live wire, it connect to the fuse, because high rating current comes means the fuse only breaks the live wire. So no current flows to the appliances. Okay. So that is the reason of the connecting the fuse wire in the live wire. Understood?
yes, ma'am.
Next. Current rating of a fuse. Already we discussed, this is also current rating of a fuse. So low current rating is 5 ampere, high current rating is 15 ampere, low current rating thin fuse is enough, high rating thick fuse is needed. Just now only we discussed about the fuse. So if the current rating is high, then we have to use the radius is more. That means thickness is more for the fuse. Okay. So now here they have given, you see. So total for home is 30 ampere, and for the commercial company purpose is 50 ampere.
Yeah.
And 15 ampere is the high rated appliances, and 5 ampere is the low rated appliances. So current rating of a fuse in a circuit is formula is total power of appliances in circuit by voltage of the supply. So this is the current rating of the fuse in a circuit. So current rating fuse. So down you can see 221 page number box. So electric bulb, television set, refrigerator, electric mixer. So these are under the 5 ampere, right? And room heater, electric iron, next greaser. This greaser is 8 ampere. Room heater, electric iron is 5 ampere. Kettle is 10 ampere. Oven also 15 ampere oven. So that are high rated. So high rated appliances. Voltage is 220 only. Understand? There is no change, and frequency also no change. Frequency also same frequency from main power station to what we are getting, frequency is same and voltage is same 220. Only the rating of the current only changing.
Yes.
Next. Okay, here they given in the page number 220 the fuse arrangement, right? Such type of fuse we are not using now. We are using what? MCBs. Small switches we are using now. Right. For the so each appliances we are using not big one nowadays. So nowadays instead of fuse, a miniature circuit breaker is
Circuit
used.
breaker.
Yes. So a heavy current flows in the line. The MCB falls down to switch off the circuit. Automatically it will trip the switch. So falls down to switch off the current in the very short time. So that means 25 milliseconds. So repairing the fault in the circuit, the MCB is then raised up. So MCB is more convenient than fuse. It avoids the inconvenience of the connecting a new fuse wire, and it is much safer due to the quick response. Before olden days, definitely we have to remove that wire and we have to put it new wire, then only it will work. But now the MCBs automatically trip. So once it comes again, we have to more current overloading only, high current overloading only, it melts. Now MCBs. Okay. So if the overload comes, it will trip ma. So again we have to put it that switch and it will work as usual.
Oh, that's fine.
Okay. So next switches. About the switches. So single pole switch and double pole switch. Right? We are having. So single pole switch is used with the applicants to start or stop the flow of current in it. So single pole switch disconnects only the live wire from the applicants. Double pole switch, the main switch at the distribution board, used to switch on or off the mains. So a double pole switch disconnects both the live and neutral wires. This is the difference. Single pole switch, Tejas? Tejas?
Yes, ma'am.
Oh, okay.
Yeah.
So single pole switch, only the connecting is live wire. So for appliances gets the current from that. So we offing that one means we are disconnecting that. Switch disconnects only the live wire from the applicants. So double pole switch means if we switch off that one, that means we are disconnecting both live and neutral wires. Dual control. So dual control switch is used, right? Nowadays we are. So double pole switches are special kind of such type of understanding. So next, reason for connecting the switch in live wire. So why the switch is connecting to the live wire? So switch should always be connected in the live wire, right? Because the applicants need the current. So live wire only functioning that gives the current. So shows the switch connected in live wire and switch S is in the on position. The applicants gets connected the high potential point through the live wire. And current flows in the applicants because the current is completely as the neutral wire provides the return path of the current. That is the off switch. So in that circuit is incomplete, no current reaches the applicants through the live wire. So the applicants does not operate. Here what they are telling means switch on and off and live wire is connecting, right? The switch, once if we on the switch, so what will happen? The current flows in the applicants. The circuit is complete as so the circuit flows in the applicants and the circuit is complete as the neutral wire. And neutral wire function is what? Return the path for
Correct.
the current. Next, off the
Yes.
switch means completely we are offing the flowing of the current. So it does not operate. So it is the safe mode. So live wire connection of the applicants can be touched if the switch is in off position. If off position only, we can touch the live wire because current flows, right. So both the live and neutral wire connected in the appliances are at zero potential. So this is important. So both live wire and neutral wire connected to the applicants are at zero potential. So here suppose bulb is there. So switch we are having here. So this is the off. So this is live wire. This is neutral wire. So live wire is what it if off means no current passing. If it is on, then current passes. Okay. Then it is disquietive and dangerous to connect switch in the neutral wire. So for the neutral wire connecting is the switch. If you are remove this neutral wire for the switch, it is a dangerous because neutral wire functioning is what? It
It sends the current.
return the path of the current.
Yes, okay. That's fine. Okay, okay. That's
Okay. So for repairing time, so the switch should be off. So that is the safe. So the current will pass through the body of the person and he may get shock if we are not off that switch. So if the live wire touches the metallic body of the applicants, that is not safe to touch the applicants. So even from the outside. Next, safety precaution while using a switch. So what are the safety precautions we have to use while using a switch? We should not use wet hands. Next, and water should not reach us to the live wire.
okay.
And next, without offing the switch, we should not repair that switch and we should not touch the live wire. So these are the precautions we have to take. Next, earthening. So local earthening. So what is the local earthening? So for the house near, for the main board, there is an earth wire. So what they will do it for that house near? So that earth wire, they'll give it to the earth. Right,
Okay.
from the main board to.
Okay.
So this is also kilowatts hour meter only. So 2 to 3 meter deep is dug in the ground. Okay. So a copper rod covered by a hollow insulating pipe is inserted in the hole. A thick copper plate of dimension 50 into 50 centimeter is welding at the lower end of the copper rod and it is burned inside the ground. Okay, this is the way the local earthing is doing. So that clearly they given in the diagram. So figure 9.22. In textbook, figure 9.22, clearly you can see. So the plate is surrounded by a mixture of charcoal and salt to make a good contact between the plate down in
Yes,
ground.
ma'am.
So keeping of that thick copper wire and hollow pipe, before in the ground they are keeping what? Charcoal and salt.
Charcoal and salt mixture of salt.
Making good contact between the plate and the earth. Afterwards, keeping an hollow pipe, in that the thick copper wire is keeping. So that copper wire,
Ma'am, I can't hear you.
so the line wires may get overheated and it cause a fire. So from that, the earth wire is prevent. Right? Next, this is for the grounding, local earthing. Next, earthing of an appliances. Each appliances again we are giving what? Earthing wire.
Okay, again.
Again we are giving earthing wire for the each appliances, because each appliance is having a certain current rating, right? That should not exceed. Again,
Okay,
see, for heavy we are taking 30 ampere, 50 ampere means more than comes means it is going, what
overload.
it is doing, overloaded, and fuse also
Overloading is short.
saving us, and one more is
Yes,
local earthing also saving that line wires completely.
yes,
So
yeah.
for example 30 ampere we are taking for our home. Okay, inside each applicant having a one rating, current rating. So
Yes, ma'am,
more
yeah.
than overloaded means what will happen, all the applicants will damage, right? So that
Okay.
preventing, again each switch we are giving one earth wire
Right.
again. So you can see if anybody is come for the repairing, you can see there is a black, red,
Red
next
and blue.
green also is there.
Green.
Green is the earth wire,
Yes,
green or yellow.
yes. Red is the live.
Yes. Okay. So now we will discuss about that earthing of an appliances. So most of higher rated appliances more need earthing wire. So if you can see for three plugs is there in our switchboard, right? Definitely they will give the earth wire. So the refrigerator, toaster, greaser, electric iron, electric cooler. So for this and all, definitely they will connection is the earthing. So the outer metallic case of these appliances are provided with a terminal on the case. The earthware of the cable is connected to this terminal. So here live and neutral wires connected from the source to the element of the applicants through the insulating plug on its metallic case. The switch and the fuse are connected in the live wire. The earth wire is connected to the metallic case of the applicants. So the earth wire is connected to the metallic case of applicants. So you can see the symbol. This is the symbol of the earthing of an applicants. Okay. So metallic case of applicants is painted. The paint provides an insulating layer on the metallic body of the applicants. Next, safety by earthing of an applicant. So what is the safety by earthing of an applicant? When the live wire of a faulty applicant comes in direct connect with its metallic case due to a break of insulation after its constant use, the applicant acquires the high potential of the live wire. A person touching the applicants will get a fatal shock because current flows through his body to the earth.